All right, folks, it's Bass Action back in action here. In this video, we're going to work through some key algebra skills that you're going to need to be able to do in the first semester of pre-calculus. It's important to know that we will be doing all of our work without a calculator. So some of the steps that I might be doing might not seem like something you would normally do. Because you would often do these with a calculator, but we're going to be working without a calculator. So the steps that I've written out here are designed to help you work these without a calculator. The first problem that I've got going on here is factoring without a coefficient. Now, technically there is a coefficient here. The coefficient is a 1, but we generally refer to this as without a coefficient. So these are the really basic ones. You're probably very, very comfortable with this. You're looking for two numbers that multiply to the constant and add to the linear coefficient. And if we looked at this one, the numbers that would multiply to a negative 21 and add to a positive 4 would be 7 and negative 3. So on those, it's really easy. You can just drop in that positive 7 and that negative 3 and you're done. And when we factor it, we would stop right here. You would not go on and tell me that the answer is a negative 7 and a positive 3, because this is not an equation. We don't know that this, for example, would equal 0. It's just an expression. Now the next one, where we want to factor with a coefficient, these are often a struggle for many students, and there are many strategies. You are welcome to use whatever strategy works for you, but if you are struggling with a strategy, I've written one out here. And this strategy is often referred to as split the middle, because what we're going to do is we're going to take our middle term and we're going to split it into two terms. And to do this process, we're going to multiply the leading coefficient and the constant, and we're going to get a 9, okay? So we're looking for two numbers that are going to multiply to 9 and add still to that middle term, that middle coefficient of 10. Our two numbers that multiply to 9 and add to a positive 10 are 9 and 1. And then we're going to take this linear term and we're going to split it into these two separate terms, 9x and 1x, using this 9 and 1. We keep the quadratic term, we keep the constant. Once we do that, what we're going to do is then we're going to factor by grouping. So we're going to look at the first two terms and the last two terms. And we're going to focus on these first two terms and we're going to factor a greatest common factor. What do these have in common? They have a 3x, and then we factor that out, leaving a 3x and an x plus 3. On the last two terms, when we look at what they have in common, often a student says nothing, but they do have something in common, and what they have in common is a 1. So its greatest common factor in this case is a positive 1. Now, this is a really important thing here. You need to always, always, always write the sign of what you're factoring and whatever it is you're factoring out. So if it is just a positive 1, you should always write plus 1 there. At this point, we can factor the GCF one more time, because if we look at this first grouping now in this last grouping, we see that they both have an x plus 3 in common, and we factor out the x plus 3. We're left with a 3x and the plus 1, and that is our final answer. The next thing we're going to do is solving quadratics by completing the square. Again, the big emphasis here is that we're working without a calculator. So often when something doesn't factor, students want to jump into the quadratic formula, and that's actually not going to be our best strategy if we don't have a calculator handy. So knowing how to complete the square is going to make your life easier. You're going to get a more accurate answer, and you're actually going to finish faster. So to review completing the square, what we're going to do, we would see that this does not factor. There's nothing that multiplies to negative 5 and adds to 8. So to complete the square, the first step we do is we're going to take our constant and we move it to the other side, and then we put these blanks on each side to remind us to keep the equation balanced. Then the next thing that we're going to do is we're going to take the coefficient on the linear term, that 8, and we're going to take that 8 and we're going to take that 8 and we're going to divide it by 2, and that's going to give us a 4. And then we're going to square that 4, and that is going to give us the 16. That's going to balance then our equation, so we put a 16 on the other side. The 4 that we got right here is then going to be the number that's going to go inside this binomial, because x squared plus 8x plus 16 factors into an x plus 4 and an x plus 4 that can be written as x plus 4 quantity squared. 5 plus our 16 gives us our 21. Then we're able to solve by square roots, and we're then going to take the square root of each side. When we take the square root of each side, on the left-hand side, the exponent is going to go away, and then we'll be left with x plus 4. On the right-hand side, we're going to get this plus or minus square root of 21. Then our final answer is to just move that negative 4 over, and this is our solution to the quadratic. We can even do this process pretty easily, even when the b value is odd, okay? Assuming we don't have a leading coefficient here, this is still, completing the square is still pretty easy to do. We're going to still move that 5 to the other side. We're still going to take our 3, and we're going to divide it by 2, and then we're going to square it. Remembering that when we square a fraction, we have to square the top and the bottom. That's going to give us a 9/4. That 3/2 is still going to become then the number that goes inside the binomial. Then we can take our square root of each side, because it's set up to solve by square roots. And when we take that square root of each side, we take the square root of the top and the square root of the bottom. So you can see in my next step, I've gotten rid of the exponent there. And you can see my square root of top, my square root of the bottom, and my plus or minus. Then we can move the 3/2 to the other side, getting it right here. Square root of 29 doesn't simplify, but square root of 4 is 2, and we're done. The next thing that we're going to look at is factoring a sum and difference of cubes. That pattern is called SOAP, okay? And I've written out that mnemonic here. So you can recognize a sum or a difference of cubes because every single part of this little binomial is a perfect cube. 27 is a perfect cube, x cubed of course is, and so is 343. So a sum and difference of cubes is always going to factor into a binomial, that's 2 terms, and a trinomial, that's 3 terms. The signs inside the binomial and the trinomial are what follow this pattern of SOAP. The S stands for same, meaning the sign in the binomial is the same as the sign in what you're trying to factor. The first sign in the trinomial is going to be the opposite of what you just did. So in this case is a minus. And the last term in the trinomial is always going to be positive, always positive. We know this first value here is going to be whatever it was that we cubed to get 27x cubed. So in this case, 3x. Whatever we cubed to get 343 goes right here, in this case, 7. The first term and the last term are the squares of these. So 9x squared came because I squared 3x. 49 was the square of 7. And then this 21x is going to be the product of these two. Now, this is all that factors. This trinomial never factors anymore. So don't try to factor it anymore. It will always give imaginary solutions. So I have one more example here. This one's my difference of cubes. So the 125x cubed gave me the 5x. The 1 is, of course, 1. These two terms were the squares. So the 5x became 25x squared. The 1 is still 1. Their product is 5x. And you can see the signs were same, then opposite, and then always positive. The last thing that is a really important skill is just always being able to find the x and the y intercepts for an equation. Remembering that when we find them, we are just letting x be 0 or y be 0. So on this equation here, if I want the x-intercept, I'm going to let y equal 0, and you can see I set that up. This, of course, is going to give me a 4, so I subtracted that over, and that got me my 14. This should now look like our completing the square process because it's now set up to solve by square roots. And you can see I skipped a step here. I knew this was going to cancel out that exponent, so I would be left with this x minus 3, so I just moved it right over. The square root of 14 automatically gives me the plus or minus. Now, Intercepts always need to be written as an ordered pair. So I'm going to take this 3 plus or minus square root of 14 and set it up as a nice ordered pair. For the y-intercept, I'm going to do the same thing. I'm going to let my x equal 0 now, though. And when I square that negative 3, it's a positive 9, and I can subtract that, and I get a 9 here. This is also set up now to do solving by square roots, and that's going to give me a negative 2 from right here. The square root of 9 was the plus or minus 3, and because these values are not any radicals, I want to clean them up. So a negative 2 plus a 3 is a positive 1, and a negative 2 minus a 3 is a negative 5. I have another one over here. I have one more. For the x-intercept, I'm going to let the y be 0. You can see that. Solving this, I moved my 7 over. And then I imagined this left side over 1, and I cross-multiplied. Now I can simply solve that equation, and again, write it as an ordered pair. The y-intercept, same thing. I'm going to let x be 0 now. That's going to give me a 6 over 3 minus 7. This, of course, cleans up. 2 minus 7 is negative 5, and I write it as an ordered pair. So if you need any more practice with this, you can certainly go to Khan Academy and find some more, or shoot me a message and I will find you some additional practice for these different skills on whichever one you might need more help. All right, that's all we've got on Key Algebra Skills.